Yeah, g'day guys. How you doing? Nico, stop complaining. We fed you yesterday, so we don't need to worry about your lunch, you missing your lunch. Can I just have a thumbs up from someone just to make sure the audio is actually working? Actually, I better put my headset on so I can monitor it. Testing. Seems okay. I guess I don't even really need it. Just waiting for a bit of that. Okay, yeah, thanks for joining me for another live stream. As you can see, I'm back here in my my little workspace, my little happy space here up in my office. I put my I just put this just so you could show what a complete mess it is. This is the first time I've not used OBS Studios to do like software switching. I'm doing it all with hardware. So thanks a lot for Alex for providing me with the switcher and with the cables to try and get this working. In itself, that's quite easy. That's not really a big deal. The issue is that this this little unit can't, you can't load videos into it to play like your intro and outros. So that's why I needed an extra bit of software to be able to do my intros and outros and stuff. And of course, once you start doing extra software, you can start getting more complicated. Alex asks, what happened to my nice, just camera one, what happened to my nice box for the Atom? It's not finished yet, of course. I was waiting for, I guess I was waiting for Godot. What was I waiting for? Yeah, no, nothing really. Just time and motivation, I guess. I have now, I did actually do the final cutout, and I need to make a little closeout panel for the back, which has all of the HDMI cables and the Ethernet cable and stuff like that. And I had big ideas that, because it was a public holiday on Friday, I went up to my mate Franz's place and videoed his grinder to this week's video, because I knew I wouldn't have anything interesting for the Schaublin because I'm still wiring. And I had in my mind that that video was going to be super easy to edit and super easy to produce. And it turned out being a bit of an editing nightmare. I'm not used to doing that style of video, you know, and Franz would turn something on or bump something, or I would bump something. We'd talk over each other, turning machines on and off, talking to each other rather than to the camera. All of that led to quite a challenge for the edit. I hope you don't mind. I hope you like what came out of it. Yeah, I did my best. So that sort of kept me busy until quite late yesterday evening, and therefore all of my plans I was going to draw up that little closeout panel in CAD and have this live stream being me manufacturing it on the CNC mill. Well, that didn't happen. So what I've got for you today is going to be a look at where I'm at with the Schaublin, with the wiring and stuff. Now, what I've been doing is I'm doing a matrix keyboard. This is kind of a typical way of doing a keyboard, I guess, that rather than using, just a sec. Oops, not fade to black. Go away black. Right. Obviously, you could theoretically do every single switch with 2 wires to every switch, or a wire from the controller through the switch to ground, in which case I would need 49 switches, and that would be very inefficient. Oh, see you later, Alex. Thanks for jumping in. So that would be, in one way, a simple way of doing switching. It would be a single switch a single wire for every switch, and a single input pin on the controller for every one. However, where's my controller? this is the controller I'm using, and it doesn't really support that number of inputs. Plus, what it does support is matrix keyboards. So a matrix keyboard is you set up rows of you set up rows of pins crossways. You set up columns of keys vertically, and then wire them all together. Let's just pop back to there. So then you can wire along your rows in one direction, wire in your columns in the other direction, and the controller sends out an input signal, like scanning through first each of the rows. So it sets each of the rows high, one after the other, and then looks at each of the columns, looking for did any of the pins on the column go high. So you can see if you've sent, let me just get a mouse over there. If you first send this row high and no pin goes high, well then none of these buttons have been pushed. Then it goes to the next row, sets that high, looking for a pin going high, and if this input pin goes high, then it knows what it can do. Then it knows which switch to activate, and it knows that the function that you've set on that position should be activated. Alexander says, I remember a CNC machine I had to repair did feed every switch with a separate wire through a spiral cable through a big industrial round plug. One wire broke and it caused too many commands to be issued, causing CAN bus buffer overflows. What a nightmare. Did you find it easy to troubleshoot? At least if it's a discrete, I guess you can go through and just do a continuity test through each specific wire to see which one's gone high. So for such a matrix keyboard, while it looks nice and simple, and the spiral cable replacement cost $250. Yeah, that doesn't surprise me for CNC materials. They're pretty crazy. Now, as you can see from my little Excel file here, setting it up as a matrix keyboard looks nice and simple and gives you sort of nice and easy sort of simple wiring. Alex says, no, it was a nightmare. I did diagnose the CAN because that's what caused the errors. Oh man, yeah. Once you start getting discretes flowing through into bus failures, yeah, that does definitely get quite challenging, doesn't it? That's the sort of stuff that where we in aviation, that's when we call in the avionics guys. It's like, dude, come and troubleshoot this for me. I'm a mechanical guy. I'll get a hammer. So, yeah, while the design of a matrix keyboard looks pretty simple in the Excel table, once you set it up with the actual, once you start actually wiring it, it gets a lot more complicated. This here alone looks like almost nothing, and yet I've probably put easily 20 hours into wiring so far, between this bottom panel and also this main panel which goes up around this main panel which goes up around the monitor. Now, one thing which complicates it is at each node you need a diode just to help prevent like ghost switching. So that adds to the complexity of the wiring a little bit. But where I'm at so far is I've managed to wire all of my I think all of my columns are now wired up. So the next thing I need to do is start wiring across the rows. Now this is the excess wire that you see here is partially the wire that's going to come out to the control module. So that's going to sit up above on standoffs. and I'll be wiring that into the pin heads. And some of this wiring also needs to actually no, I haven't. Yeah, all of this loose wiring goes up to the pin heads. I've wired what looks like a row. Sorry, I was on the wrong thing there. So what looks like a row on the Excel file is in most cases like a row across here, then I need a jumper across. I'm going down this way, and then that gives me my 7 pins, down there and down there. This one I think is going across here and down the middle, and this, well, that may be this one. The white one goes down here and across the middle, and this one goes across here and down this way. So that was all the kind of easy and logical wiring. The next part is going to be a real rat's nest where I have to pick up one switch here, one switch here, one switch on each of these crossways. Those are already hardwired in. Switch across to there, and then jump up to one switch up here and one switch on this row. So I haven't yet decided how I'm going to finish this off, but I'm definitely going to need a 14-pin connector to be able to disconnect this panel from that panel, because I don't want to hardwire it. I know if I hardwire it, I'm going to make... damn, I'm on the wrong one again. Sorry, let's try that again. So I need to go pick a switch here to here. I'm going to need to pick up one switch here, 3 across here, 1 across there, and then go up to 1 up here and 1 over here. Let's show that a bit closer. And then 1 here and 1 over there. So that... Oh, g'day, it's Stephen. Thanks for joining. Didn't get a notification. Sorry about that. Okay. Anyway, so I'm going to need a 14-pin connector to be able to wire each of these ones to a disconnect. No, I guess it's only a 7. No, I need 7, 8, 9. Yeah, 10. I need a 10-pin connector to be able to disconnect this panel from the lower panel. And I need that because, I mean, I could mount both panels and then start wiring, but I know I'm going to end up with just a rat's nest and have it such that I can't possibly troubleshoot without having to work in around that really heavy control panel. Alex wrote, the best way would be to route some custom PCBs and get them manufactured. I did consider it. The problem is I've never used any PCB software other than Eagle. The free version of Eagle is only limited to like a half euro panel size, and I would need like some much bigger PCB to be able to interface all of these switches. And yeah, I don't know the software. I figured learning the software would take me a lot of time as well, and yeah, I just decided to do point to point. Oh, g'day, Luke. Luke from Malta's joined us as well. Yeah, it is setting. I mean, it's actually a pretty simple concept. You know, you're basically just setting up. You got to picture in your mind what are my rows, what are my columns, and then be very systematic of wiring. Pick a color, I guess, is also helps. You can see I've given a set of colors down there, and then just be very systematic of like what is my Excel table tell me. It says take this button, wire it through to this pin, wires through to this pin, wires through to here, wires through to here, goes through there to there to there. Nothing that complicated about it, but you do end up in practice having about like 100 little segments of wire that every single one needs stripping at both ends, soldering at both ends, maybe some heat shrink in some locations. So it does take a fair bit of time, but that's the nature of wiring. So this is the main reason why you haven't seen me doing anything on the Scholblin for the last few weeks, and also why you've seen me using the Bolly lathe for my last couple of videos, because the Scholblin's basically lobotomized. The head unit, the computer and stuff's all scattered through the workshop, and like, and I robbed its monitor to use for this part of my live streaming today for my multi view. So yeah, that's the reason why you haven't seen the Scholblin involved in any of my videos lately. Yeah, so what I was going to do is just let's see where I was at, and let's wire up the next bit, huh? So let's go to now. Whoops, I want camera 4. So I had done all of the columns. So by the way, this module can support an 8x8 matrix, but I'm only going to use a 7x7 matrix because I only need 49 switches. The extra row and the extra column, the system will scan it, but if it's not connected to anything, it just means that all of the phantom switches on that row and on that column are just not being pressed. The machine doesn't care what you don't use effectively. Alex wrote, easy EDA would be an option if you have a future need for PCBs. Okay, I don't know that. I'll have to look into that one. Haven't heard of that before. Thanks. So, looking back here, what did I do? This column here is this column down through here. So that was easy. That's just all connected together. And then the output from this wire still needs to be run as a single wire to my to this controller. Down along the bottom here, I've got 10 buttons, and because I'm only doing a 7x7 matrix, this second column is 7 of them, and then the extra 3 go into the third column. And you can see that in my wiring color, so I've got these 7 connected together, and then these 3 connected together. And I still need to run their pigtails out also to get to the controller. Because I had those 4 buttons left over, here. Because row 3 had 4 buttons left over, and I've got 4 micro switches on my joystick, this one's this will complete that final row from the top panel with those 4 switches. So we need to connect into here as well. Then things get a bit complicated. The next row is basically one of my little panels for 3 switches, and one of my and all of a row along my big panel, and the same for each of those, and that gives me my 7. So the next thing I need to do is now start working horizontally. So this is a button up on that top panel. This one, I'm going to put that away and ignore that for now because it needs a disconnect. The second one's also on the top panel, the third one's on the top panel. But the fourth one is going to be, if I can read it, my turtle jog button. As you can see, I have written on the back of them here a bit. Oh, by the way, because this little Mesa pendant interface card also has output pins, and I think I've got at least 8 output pins available, maybe even more, because I'm not using an LCD display. I decided to add LEDs to light up some of the buttons, the ones which make sense. Not every button needs them, but the ones where you have like a variable state, I decided to add coloured lights to them. Alex wrote, can you explain the diodes usually only required for Charlie plexing? I just looked into a bunch of videos talking. Let's try to get back to the. I just looked at a whole bunch of videos, because this is how I learn things, about matrix keyboards, and it was recommended that once you get beyond about a matrix of, I think, 4x4, it is recommended to add diodes just to prevent ghost switching, or, yeah. I didn't really question it too much. It's like, you know, YouTube and internet wisdom. It's things to be accepted blindly, isn't it? That's the way I do it. Alex, yes, the way you can reverse the polarity and light up and pole 2 LEDs, 2 switches. Okay. Yeah, so in my case, there's no direct interface between the switch and it being pushed and the LED being powered up. The switch is being scanned by a set of input and output pins for the matrix keyboard, and then Linux CNC, based on machine states, will be lighting up will be activating output pins, which then light the LEDs. So you'll be pushing a button, lighting up an LED, but it'll be an indirect function being done by Linux CNC. If it all works. Wish me luck. I guess in German it's we hold your thumb for luck. There you go. Yeah, so that's the concept, at least. I've already spent a lot of time wiring, and that was the easy wiring. Now comes the hard stuff, because I've got to bounce around the whole thing. Where am I at? 4. So in this case, what I'll be need to do is connect turtle jog, which is this pin, with the stop button, which is on this one, and with flood coolant, which is over down here. That's this one, and I've probably got one more, which is off. Wait a minute, 1, 2, 3, 4, 5, 6. Yeah, it's off the edge of my Excel table. Not that easy to do this because I'm in multicam view. Oh no, that was the end of it. 3 of them. Oh yeah, sorry. No, I don't have 49 pins. Oops. So I was just looking at this. I do not have 49 pins. I've got 42. So it's going to be a 6x7 matrix. Yeah. What I did do is, up here are going to be a bunch of encoders. So up here come 3 encoders. One of them's going to be for jog override, one's going to be for feed override, and one's going to be spindle override. And each of these actually has a button. So I originally was going to put those buttons into my matrix keyboard as well, but that would require me to wire up an extra row. Plus, these buttons, they have a common ground pin with the potentiometer, with the encoder, and all the rest of the buttons are not going to be referenced to ground, because you'll be going in from an input and out through an output. So having that reference to ground doesn't really help me. So what I decided to do is run those 3 switches just as extra discrete straight into additional I/O pins on this board, which also then gave me the advantage that this whole thing is restricted to only a 6x7 matrix. which does at least reduce some of my wiring. Yeah, so that's the concept at least. The question is, do I start wiring in front of you and waste your time watching me snip wire, strip wire, and solder wire, or do I call this the end of the live stream? Because realistically, watching somebody else wire is about as interesting as watching paint dry. So I think I'll let you guys go. Actually, I think that's probably the best. That's probably a good stopping point for this live stream. Nico needs to go and get some lunch, he said. So let's let him go and get his lunch. And yeah, I will do a video on this once I've got the whole control panel wired up and configured. It'll be a much simpler summary because I can edit out all my ums and ahs and all of my self-confusion. But I just kind of want to give you a bit of an update on what I've been up to on the Schaublin and why it's taking me so long to make the next Schaublin video. So yeah, that was a live stream. Thanks a lot for joining me. And yeah, next time I'll do one in the evening for the people in the United States so that they don't have to get up at super early. Thanks a lot for watching. Have a good lunchtime. And Doric, have a good breakfast. That's on 4.